Dear children, the remaining part questions of the last lesson will be given to you in the due course. Now we are going to see the new lesson, understanding the quadrilaterals. Third lesson, understanding the quadrilaterals. The blackboard, this surface can be considered as a plane curve. Plane curve. Then, what do you understand by polygons? Polygons. A simple closed curve. Simple closed curve made up of only line segments is called a polygon. A simple closed curve. For example, this is a simple closed curve made up of only line segments A, B, C, D. AB line segment, BC line segment, CD line segment, AD line segment. It is a closed, simple closed curve. Simple curve which is closed. Such a shape is called a quadrilateral. 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 Four-sided polygon. And this is also a polygon. Polygon means a poly. Many. Guns means sides. Closed, simple closed curve with many sides. ABC is a triangle. This is also a simple closed curve. We know that this has three sides. So this is a triangle. This is also called a polygon because this is a simple closed curve. To see this, this is not a closed curve, closed figure. So this is not a polygon. Not a polygon. So we can classify polygons, figures which are polygons, which are not polygons. So a polygon is a simple closed curve made up of only line segments. Line segments. Now, what are the? Can you give some polygons which are familiar to you? Triangle, quadrilateral. Four-sided, quadrilateral, pentagon, hexagon, octagon, etc. These figures, all these are closed, simple closed curves. So they are called polygons. Many-sided closed figure. Polygon, many-sided closed figure. Now, what do you understand by the diagonals of a polygon? Diagonals. Consider this figure. This is a polygon, rectangle. This is also a polygon. We can join A and C using a line segment. These are the consecutive vertices. Consecutive A, B, C, and D. A and B are consecutive vertices. B and C are also consecutive vertices. C and D consecutive. D and A. A and C are non-consecutive vertices. And B and D are also non-consecutive vertices of this polygon or quadrilateral ABCD. And we can join A and C with a line segment. Also, D and B and D can also be joined by a line segment. Such line segments are called the diagonals of the polygon. Diagonal. So AC is a diagonal. segment AC, or simply AC. DB is also a diagonal. So quadrilateral ABCD or polygon ABCD has two diagonals, AC and DB. Now what are the diagonals of a polygon? Diagonals of a polygon are line segments joining two non-consecutive vertices. Diagonals are line segments joining two non-consecutive vertices of a polygon. Now see, this is also a simple closed figure, so which is also a polygon. A, B, C, D. A, B, C, D. Now, what are the non-consecutive vertices here? A and C, B and D. Let us join with this line segments. Line segment. So AC is a diagonal. BD is also a diagonal. AC and BD. AC and BD are diagonals. Centimeter diagonals. Now compare these diagonals. Here AC and DB are diagonals of the quadrilateral, and these diagonals are inside the figure. Inside the figure. Here AC is the diagonal which is inside the figure, and DD is outside the figure. So the polygons having all the diagonals inside the figure is called convex polygon. Convex polygon. If all the diagonals are inside the polygon. If any one of the diagonals is outside the polygon, which is called a concave polygon. Concave polygon. Convex polygon and a concave polygon. Or convex polygons. Concave polygons. What are concave convex polygons? Polygons having all the diagonals inside it. And if the diagonals are or diagonal of any polygon is outside, then such a polygon is called a concave polygon. Interior and exterior of a closed curve. We are familiar with the interior of a figure or exterior of a figure. Interior and exterior of a closed curve. See this. This portion of this closed curve is the interior. Interior. Then exterior. Outside version. Exterior. Exterior. Interior. Interior. This shaded portion is the interior of the closed curve. This portion is the outside portion is called the exterior of the closed curve. Now, regular polygons. Regular polygons. What do you call a triangle having all the sides equal? It is an equilateral triangle. Equilateral triangle. And we mark all the equal sides in this manner. This is an equilateral triangle. It's an equilateral triangle. What are the properties of this equilateral triangle? All the sides are equal. Also, all the angles are also equal, and each angle is 60 degrees. 60 degrees. Now consider a square. Square. What are the properties of a square? all the sides are equal, all the angles are also equal, and each angle is 90. Such a type of polygons are called regular polygon. Regular polygon. What is the peculiarity of a regular polygon? They are equiangular. That is, all the angles are equal, and they are equilateral. That is, sides are also, all the sides are equal. So a regular polygon is a polygon in which all the sides are equal and all the angles are equal. Or in general, we can say that a regular polygon is one with equiangular and equilateral. Equilateral. See, if these two sides are equal, but the third side is different, so this is not a regular polygon. It is an irregular polygon. Irregular polygon. So we have learned some important aspects of polygons. What are polygons? And what are the diagonals of polygons? Regular polygons, exterior and interior, etc. So all these are illustrated in the textbook. So you read the pages of the textbook from 36 to 40, and some figures are given in each page. So copy all these figures in your study book, all the figures, and tabulate it. Also, do the exercise 3.1 question 1 and 2. Thank you.